Good afternoon, everyone. Today we're going to do an example where we look at the transformations on a parent function y is equal to x squared, that is the very first parabola that we all saw a few years ago, to obtain 3y is equal to brackets negative 1 half x plus 10 all squared plus 6. And then with those transformations in mind, we're going to write a mapping rule for any general point xy that falls on the original curve. Okay? So let's go ahead and start off by noticing that we don't quite have this equation in the form y equals so and so yet. So let's go ahead and do that first of all. Let's divide both of these sides by 3, get our y nice and isolated. So dividing by 3 we know is the same as having 1/3 in front to multiply. And so we'll have 1/3 times this bracket, negative 1 half x plus 10 all squared. And then we can go ahead and divide through by the plus 6 over 3 at the end. And so plus 6 over 3 means plus 2 for our vertical translation. And now we're not quite done yet because we don't have this in the form b bracket x minus c bracket all squared, right? So we need to factor out this negative 1 half in front of the x to capture both terms inside of that bracket. So let's go ahead and do that. Y is equal to 1/3 times negative 1 half bracket x. And now we have to think to ourselves, negative 1 half times what would give us back our original plus 10? Negative 1 half times negative 20, right? Because negative 1 half times that negative 20 would bring back the plus 10 if we were to multiply that through, okay? But we won't, because we want this to be in transformational form so that we can easily read off the horizontal translation and the horizontal stretch. Okay, so let's go ahead and finish that off. Now we have this in transformational form. Okay, so we can easily read off our 4 transformations and potentially reflections. So let's start off with, let's use a different color. Is there a horizontal translation? Certainly, x minus 20 tells us that we have a horizontal translation of 20. Okay. Next up, we have a vertical translation, plus 2 at the end, and so our VT is positive 2. Next up, we have a horizontal stretch, right, which we know to always be 1 over b. Okay, we can get into that a bit later, but when we have this in the form a bracket b bracket x minus c plus d, our horizontal stretch is always the reciprocal of this b value. And so since our b value is 1 half, we're going to leave the negative out and leave that to be described by a reflection. Our b value is simply 1 half. I'll make a note of that. And so our horizontal stretch is 1 over b, or we can simply think of taking the reciprocal, flipping it, and so we get a horizontal stretch of 2. Okay, one way to think of it once we get to graphing is that horizontal stretch 1 half means the graph is twice as long. Okay, but anyways, we'll get into that again when we get into the graphing portion things. And then finally, we have a vertical stretch as well. The 1/3 out front signifies a vertical stretch of 1/3. So the graph is going to be 1/3 as exploding, I guess, one way to describe it. And finally, we do have a reflection. The reflection is not outside of the square, right, which is really our original parent function. The negative is tapped into the part of our function that is being squared, and so that negative is attached to the x, okay? So that means that we're going to have a reflection, if we can imagine our graph, we're going to have the x value be reflected, right? So here we would have x on the y, and over here we would have negative x on the y. So when the x changes sign and gets reflected, that's a reflection about this vertical line, which we know to be our y-axis. And so we can refer to this as a reflection in the y-axis and simply make note of that down here. And there we are. So we have 4 transformations and a reflection, so maybe 5 transformations if you'd like to think of it that way. And now we can go ahead and write our mapping rule. I'm smudging here on the board. Let's fill that up. So we want to write a mapping rule for any general point x comma y on the original parent function y equals x squared, and so we can go ahead and do that. Any point xy, once it undergoes these transformations, on this curve will fall on the coordinates. So the x becomes reflected because we have a reflection in the y-axis, so that x coordinates become negative. So we can start with negative. Our horizontal stretch is 2, so we're going to have negative 2x, and then plus our horizontal translation being positive 20, and so negative 2x plus 20, okay? And now for the y's, there's no reflection in the x-axis, the y coordinates aren't being reflected, and so all we have for y is a vertical stretch of 1/3, and then a vertical translation of positive 2, and so we're going to have 1/3 of y, and then a plus 2 to finish things off. And there is our mapping rule for any point on the curve of our original function. Okay? So I hope this helps. If you guys have any comments, suggestions, queries, please leave a comment down below. Thanks for watching.